Hi, my name is Jonathan F. Gonzales from 2ITJ under CS2 7 Operating Systems in the class of Abisado. So today I'm going to discuss two diagrams, which are the MS-DOS execution and the Solaris modular approach. So let's start off with the first diagram, which is the MS-DOS execution. But first, what is MS-DOS? MS-DOS stands for Microsoft Disk Operating System. According to Computer Hope, MS-DOS is a non-graphical command line operating system derived from 86-DOS that was created for IBM-compatible computers. It allows the user to navigate, open, and otherwise manipulate files on their computer from a command line instead of a GUI-like Windows. So here is the diagram of the MS-DOS execution. As you can see, in diagram A, at system startup, the command interpreter is invoked. But in diagram B, when the process is launched in DOS, the command interpreter first unloads as much of itself as it can free up memory, then loads the process and transfers control to it. The interpreter does not resume until the process has completed, since the MS-DOS is a single tasking system. That's it, simple as that. So moving on to the second diagram, which is a Solaris modular approach. So on the second diagram, we're going to talk about these modules, particularly loadable kernel modules of the Solaris operating system. So to give you a short background, Solaris is a unique operating system with the microkernel design, originally developed by Sun Microsystems, but in 2010, it has been owned by Oracle Corporation and changed its name to Oracle Solaris. Let's move on. As you can see, the core Solaris kernel is located at the center of the diagram. So the kernel here is the core of the operating system, whose primary functions are to manage the hardware by allocating its resources among the programs running on it, and to supply a set of system services for those programs to use. This is basically the heart of the OS. So around the core Solaris kernel, these are the set of core components and links in additional services through modules. So these components are called loadable kernel modules. Namely, these are scheduling classes, file systems, loadable system calls, executable formats, streams modules, miscellaneous modules, and device and bus drivers. So all of these services can also be implemented in Linux, Mac OS X, and Windows. So the concept of this design is for the kernel to provide core services while other services are implemented dynamically as the kernel is running. So what are the advantages of these modules? The loadable kernel modules mechanism provides this dynamic capability to the operating system kernel by loading or unloading modules in response to system calls or the kernel's resource requirements. Furthermore, these modules can be developed, tested, and modified without having to add the code to the kernel, recompile the kernel, and reboot the system. So this approach is similar to the microkernel approach, but the kernel does not have to implement message passing, since modules are free to contact each other directly. So that's it. Thank you for watching.